Well, hello, hello. Welcome to Lecture 10, brought to you today by Michigan State School of Packaging. Today's featured letters are PKG and the numbers are 450. I know that's a corny Sesame Street joke, but trying to make sure you all are paying attention. Okay, all right, so we are starting on chapter 4, which talks about how to select containers. Oh, I see Brandon actually laughed. See, Brandon's shooting for an A in the class, obviously, because, okay. Seriously though, chapter 4 is how to select the container that you need, how to determine how many parts go in a pack, and how that impacts things like transportation. So those are some of the things we'll talk about in chapter 4. Let's see, I'm going to share my screen. Okay, can you see, Brandon?
Yep.
Okay, great. All right, so first we have here, as I mentioned, when you're looking at things like returnable containers, how do you choose between a handheld tote versus a bin? When to use a rack, all those types of things are dependent upon the type of part, the material, the requirements for protection, the requirements for line side display, the amount of room. There are so many factors that go into this. It seems like it's endless. However, there are some general, I won't even say standards, but kind of rules of thumb that people use, and some tools that they use to come to these decisions to help determine what is needed. Sometimes, you may be forced into a handheld tote, even though a bin might end up being your best choice, for example, because besides the packaging engineering team, you've got the supply chain team, manufacturing, what's called advanced manufacturing, or an engineering group that lays out the floor. They may only allocate so much space, so that would actually can determine, what size or what type of packaging that you have, your route. There are just so many different things that go into this. But again, we talk about things like metal parts for your body, for the body of the vehicle, for example. Those generally get shipped in racks, because they're heavy and large. Things like engines, you'll see carpet seats, the trim parts, which would be plastic parts that go along maybe the edges of parts of your vehicle that will maybe cover up imperfections or gaps in the vehicle, or maybe used, to keep the metal, the painted part from getting scratched or something like that. A lot of those are shipped in racks. Parts for engines. So some of the engines, when they're made, when they're finished and they're going to the assembly plant, they could be shipped on racks, but the parts coming in, many of those get put in trays. So thermoform tray or vacuum form tray, things like that are used because they can protect the part. They're stiff enough to hold the part. They can be formed in a mold. And when you have tooling, you are repeating, it's a very repeatable shape that you're putting in the tray. So that would be needed if you have parts that are either machined or picked in place. So if you have a part that's going to get on at the line, it's going to get picked by a robot, it needs to be able to locate that part. A lot of machining equipment for parts, some of the parts that get machined, they may either come in a tray before they get machined, or put in a tray, placed in a tray after they're machined, because they're machined with a system that they can key in or type in or program in what that machine part should look like. So it's moved with a robot, cut, shaped, and then put back into a tray with the robot. So you're looking at precision for those. And then those trays get shipped on a plastic pallet. Sometimes they might come in a bulk roll pack. So back to my examples, right? So as an example, let's pretend that this is a tray that is thermal formed or vacuum formed, and they stack. So these can get stacked on a pallet, or they may even get stacked inside of a bulk bin. So, that's how they get shipped. Trim parts, a lot of times they're lightweight because they're plastic. So they may not be heavy, but because they're so big, they will end up getting put in something like a roll pack. And then those roll packs or large bins will have some sort of dunnage that's usually cellular. So in some of the videos and some of the readings that you've seen in the past, you would see a roll pack. Maybe it's a bulk container that's been customized, and you will see the dunnage that is a cloth or plastic that has a long hole in it, and you can put the part or pull the part in and out of that, and it separates those trim parts. So especially if they're Class A surfaces, it keeps them from touching each other. And some of those trim parts might have metal clips on them. So if that metal clip rubs up against the A surface part that's visible to the customer, that could cause damage. So you will see partitions in those custom bulk bins that will hold those parts and keep them separate and protected. And sometimes, you'll see these parts come in the small handheld totes as well, because they're lightweight. And as we talked about in the last chapter, some of these parts that get put into totes, the weight limit. So the totes may be able to hold, let's say 100 pounds, but the limit is going to be what can be moved by hand. And where OSHA, I think, says 30, 35 pounds, in automotive, they'll stop somewhere like 25 or 30 pounds. So they're looking at, can a middle-aged woman like me, but I'm not 5 feet, but let's say a 5-foot female that is middle-aged working in the plant, is she going to be able to handle carrying this container all day long? So you want to minimize the number of stations where you have what they call the basketball team back in the Rouge River, in that Fort Rouge River plant video where they had those tall guys. So you want to eliminate that whenever you can. And that's where that limitation on the tote, a handheld tote, is going to be basically what a female that's not real strong can lift. So those are just some of the things that you see. I'm going to show you next some decision charts. I have seen these. The first time I saw it, I'm like, what in the world is this flow chart? This doesn't make any sense. But as I started working in automotive and started seeing how many different things go into the decision, how many things impact the packaging from the very beginning, when the part's first made, and understanding the characteristics of the part, all the way through as it travels, as it gets shipped, as it gets stored, as it gets pulled on the line, and as that tote, if it's returnable, as it gets moved back, or if it's not returnable, if it's expendable, how it may be put in recycling or composting or a compactor or wherever it might go, looking at the end of life, just looking at that whole range of what happens to it. Now it makes more sense what these decision charts are about. So this one is saying that really you want a small tote. The decision chart is trying to drive you to small totes. So this is probably going to be more in line with the company that makes smaller parts, lightweight parts. Maybe they need to be protected, maybe they don't. Shipping shorter distances because they're looking at returnable totes, but you'll see. And here, the smallest tote that's selected, they want to be less than 30 pounds. We talked about that weight limit. And the tote should not contain less than 20 minutes worth of parts. So that goes along with what we talked about, the takt time, and when the delivery drivers are running routes. So let's say they're running a route and it's set to every 20 minutes. So they know every 20 minutes they would either need to deliver a tote, or maybe if they're trying to do 2 hours worth, maybe they deliver 6 totes at a time. So when they come back on that route, they're only coming back, every couple hours, or maybe they put 3 totes for an hour. Whatever it is, that 20 minutes ties into that 60-minute tack time that tends to flow throughout many of the automotive plants, whether it's an assembly plant that's assembling the vehicle, or even some of the tiers that are supplying parts to the assembly plant. Then this talks about the bulk bins. If you have to use bulk bins, if you go down this flow chart, it starts driving you towards bulk bins. You want to use the smallest one possible. And the limit there is the capacity for the weight of the tote. So you want to make sure that the tote is strong enough to carry whatever weight it is. So if the parts are a little bigger and heavier, then you want to make sure that they're not too heavy for the bin. And that even goes to looking at the capacity of the truck. So make sure you're not going to weigh the truck out as well. And for the larger tote, you're looking at 4 hours worth of parts. And the other chart is even more complicated, but basically you're driving towards the same things, whether you're going to a smaller tote for a limited time period that's dependent on when drivers are delivering, the time with the tack time or the cycle time that the operators are building the vehicle, and as that vehicle moves to the next station, or if it's a bigger part or heavier part, using larger bins. Okay, so let's dig into these decision charts. Brandon, do you have any questions before I move any further?
Nope, I'm all good.
Okay, so decision chart number 1, select the part in question. This seems pretty obvious to us, but you would be surprised how many times me working in automotive packaging, I ask someone the size of the part and they either don't have it, or they say it's not fixed yet, or they say, what do you need that for? So it's important that if you don't have a part that is, if not the actual size, very close to what the final size is going to be, which would be a production intent part. So it's as close to production as you're going to get without making it on high-speed manufacturing line or something like that. But it's a really good prototype that gives you the size. If you don't have that, then you want an accurate drawing. And a lot of you may have taken a mechanical drawing course, a CAD course. And when you learn how to dimension a part, and you'll see with packaging, you're going to do 3 dimensions, of length, the width, and the depth of the part or the package. But for some reason, automotive, they generally only give you 2 of the 3. So it's kind of like an equation with an unknown. And I've never asked why they do it, but my best guess is that they do it because if for some reason a competitor gets a hold of this drawing, the competitor would have a really hard time really truly replicating that part. There's a spirit of competition in automotive, and I've not seen it, but I think in the past there probably was a lot of stealing of knowledge or intellectual property. I don't have any proof of that, but just based on how careful people are with the drawings and their intellectual property, I come to the conclusion that this is probably has been the case in the past. Another thing you'll notice in automotive, so I'm getting off on a slight tangent, but dealing with the parts, another thing you'll notice with the anytime you work in a program or a new vehicle, you're probably going to hear 3 different names. One, and the only other industry I've seen this in was computer packaging. You're going to have the name of the vehicle, like in the model year. You're also going to have a name that maybe the supplier suppliers have for it. So then you also may have a third name that would be like a code name that is getting used. And the code name is so that if anyone hears you talking about, let's say you're at Starbucks and you're talking to your coworker about, say, the new Escalade, instead they're calling it Apollo or something like that. And that's for, just to be certain that no one knows what's happening. For those of you that live or have spent time in Detroit, you'll probably every once in a while you'll see a car that's black and white and has like, some sort of cover over it, or the paint job has triangles or some odd shape or something like that. Usually that is because they're trying to keep it secret. So the reason why they're doing that is, for intellectual property. That's really what you're going to see. So back to select the part in question. You want to make sure you have a good part, or the drawing. So again, the drawing's probably only going to have 2 dimensions on it, and you're going to have to either ask the engineer, or if you have software where you can open the drawing and measure it, you can do that as well. But you need to know what the dimensions are. It's really important that you do. I'm sorry, just 1 second. Okay, it's hard to noise. I think someone's trying to race outside. It's a nice day. Okay, so the next, you have your first decision. Once you have your part, yes or no. Will the parts fit in a standard tote? So you can already see first decision is, can you put in a standard tote? So the hope is yes. Next one is select the smallest standard tote into which the parts fit. So if you have a part that is, 14 inches long, then you're going to look at a tote probably that's 15 inches long on the, inside dimension, that's somewhere in that area. And then once you do that, you try to see how many parts you can fit in that tote. Again, you're looking at standard sizes because you're assuming that these are going to be going on a rack line side, which we saw in the Ford Rugy video. We saw a bunch of racks, and we saw boxes and totes and bins, and next to that you might see racks or the bulk bins or pallets next to the racks. But the racks tended to have a smaller bin, and then the parts were usually, at an angle coming down that rack. So you're trying to find what tote you could use to go on one of these line side racks. They generally tend to be, they have some adjustments. You have certain standards of widths and lengths that you have, and even the height, but those racks can be adjusted to fit for those standards. It's sort of a modular format for those. Okay, so once you fit that tote and you see how many you fit in there, next thing you do is check the weight. Does the tote weigh less than 30 pounds? Yes. Okay, keep going. Then your next one is, you're looking for at least 20 minutes worth of parts. So let's say this part's 15 inches long. But you can only fit 3 parts in there. Yes, it weighs less than 30 pounds, but 3 parts is only going to last you 3 minutes, maybe not that much. So now you're back up here. So you're going back to a larger standard tote. Let's say yes, you did. You go, and then you go through the exercises again. Does it work? Maybe you get to a point, you keep doing this, and then you hit 30 pounds. And you go, no, so then you're gonna go back to the one before that. So that's kind of how this works. It's a pretty standard flow chart, but you can see some of your decision points. First is, does it fit in the standard tote? The other ones, no, it does not fit in the standard tote. Then you're looking to see, is it going to fit in a standard pallet box, which again, is going to be something like a box like this, but it's got a pallet on it. Or it's going to fit into a bulk bin. So this one, it focuses on either a standard tote or a pallet box, which is going to be something like a roll pack or a bulk bin. So you're doing the same thing where you're filling that with as many parts as possible. And instead of the weight being 30 pounds for a handheld, which is going to be a constraint for a worker physically, then the constraint for the bigger pack is going to be the weight limit that the actual container can hold based on what the manufacturer has rated it for and what the manufacturer has tested it for and what they've designed it for. You can see you have nose and you just can keep going. But again, you can go through this loop. So when you look at it, initially it looks fairly complicated, but as you start going through each portion of that flow chart and you get to each decision point, it makes it pretty straightforward for you. Once you get through one of these two loops, you would keep doing this until you get to, you go on the loops until you get to the right size container. And then once you get there, you say, are there at least 20 minutes worth of stock? Yes. Does the standard pallet box hold 4 hours worth of stock? So that's the difference with the bulk bin. They're looking to hold 4 hours, right? Versus 20 minutes, because that's going to be sitting by the line. It's going to get delivered, say, with a fork truck versus someone coming on the tugger and delivering boxes and handheld totes to various stations throughout their cycle. So here you've made the selection for the container. And then you want to know, is export packaging required? And for this one, you would utilize whatever your guidelines are. And this tells you what to do. So every company is a little bit different, but right here, every company has guidelines and standards. I probably can very quickly show you what, let me see. Let's see, it's gonna go in here super quick. Over the years, I've kind of collected standards for packaging. Okay, I think this is it. Oh, that's not it. I don't see it, but I have a lot. I have like, where are they? I'll find them, but I've got like Nissan, GM, here's one, Bosch. I have them saved somewhere. Let me see if I go to Bosch, because I would like to show you. Okay, yeah, so I've got here Bosch, Continental, Denso, Forcia. This is now Stellantis, Ford, GM, a company called Hello Logistics, Mazda, Magna, Mali, Nissan. So I just kind of kept these over the years because they're really good to refer to. Vallejo, these are all very helpful for me to see, what the standards look like. Many of them would have a document like this flow chart within their guidelines. So you can see, so here it says utilize the guidelines for export packaging. But when you do that, they need to contact, for this company, they would contact what's known as their packaging and central engineering, because it's export, there probably some special circumstances that they need to make sure they're packing for and alert people to. This one, if there's no export packaging required, this is telling them what to do. This is probably some form to say, this is the packaging that I've selected. Some companies might call it a packaging data form. Other one might call it a spec sheet. It just depends on the company. And then this particular one, they have like some sort of container management database system. So some companies have systems, some companies just put everything on a spreadsheet. It just depends. So they not only are they telling them to select the container, but once they've selected it, they're telling them where to go to either get it approved or record the decision. Okay, going back up here, if you just get a bunch of no's, so here you've gotten to yes, but let's say here you've gotten to no, and you try to get a small tote, no, you couldn't get a small tote. You go here, it won't fit in a standard pallet box. The weight limit for the manufacturer is below the weight of the part. The part is larger than a standard row pack or bin, is larger than any standard that's available. And even if you did all that, got past all that, it still wouldn't hold 4 hours worth of stock in a bulk bin. So now you're going here again to central engineering, and now you're managing by exception, because this one maybe requires a rack. It maybe requires a bulk container that has customized dunnage and requires extra time and development for prototyping and development of the actual pack. So that would be an example of what a standard decision chart looks like. Okay, this decision chart, a little bit more complicated, but basically the same thing. Hopefully you all can read this. I know it'll be in the reading, so you can look at it again later. But okay, this one start. Did the quote package include a recommended container and estimated quantity? This is important to know. Remember the last chapter where I was saying you want to make sure that as a packaging, your packaging function gets involved with the program management team early. So even at the phase of the concept of we're making a new vehicle, and it's going to be the exact same vehicle, except it's got different headlights and the engine's going to be bigger, or whatever those changes are. And then you're really going to try to manage the new packaging and any packaging that you knew was an issue for the previous vehicle that this is replacing. But right here where it says, did the quote package include a recommended container and estimated quantity? The reason why it's so important to get involved early is because if not, now you're kind of living with whatever was decided on. The process to get something changed once the costing has been put in and the program team or purchasing has kind of approved it, it's going to be really difficult to get that changed. So I can give you an example that I'm dealing with right now with one of my clients. They brought me on, but they had already started working on packaging. So the product engineers are developing packaging, supply chains working on packaging, and even the commercial team was working on packaging. So commercial team, they work a lot with purchasing. They're kind of like half purchasing, half finance. So they come up with costing, they determine how much this new vehicle or this new part is going to cost, including everything that goes with it, labor, their sales and general administrative costs, your packaging, everything that would go into the cost for this part or this vehicle. That's what they do. So many times at this early in one of the early phases, suppliers may be submitting quotes to say, for this part, I'm going to make this part, and oh yeah, my packaging is going to cost $1. Well, they're just saying, my packaging, I'm going to put it on a pallet, standard pallet. They're paying maybe, let's say $10. We'll give them $10 for this, right? So they put in their quote, they're going to put 100 parts on. Well, let's say they're going to put 10 parts on this pallet and they're paying $10 for the pallet. So they're going to say the pallet is $1 per part split up. Okay. So when they do their quote, they tack on $1 for that part. for the packaging. So now the team is thinking it's only going to cost $1. And then they start costing their part to either whoever they're selling it to. So they say, okay, this part is going to be $3 and $1 of that is going to be this pack. So they're counting on that. Well, let's say that this pallet comes in and these parts are delicate or whatever, really, they're small. Well, instead of coming on a bulk pallet, maybe they should have just come in on a small tote. But that means it would come on a returnable pallet. Now that returnable pallet is, this thing might cost $100 versus the 10. Commercial team will go, oh my God, this is now $100. And we thought it was going to be 10. But they're not looking at this is getting thrown away many times over. This is going to get reused. So what they're looking at is per piece what this is, and they're not calculating what this is over the life, of the whole program. So now the cost calculations that they've done are not really based on returnable packaging, or it's based on maybe a different tote. So now you're living with a particular tote because let's say that they quoted this one cost $100, but this one, which has some special dunnage in it, is $125, so it's $25 more. And they're like, well, we didn't put that in our quote. That's not what we were bidding on. That's $25 over our budget. So now you're living with this bulk bin without any dividers, but these parts are hitting each other. So when they get to the assembly plant, they're scratched and they can't use them. So they're throwing away 25% of what's in here. So they're actually spending more throwing away damaged parts. But when that decision is made early on with the quote package, they recommend a container without dunnage. So that's because they didn't know. You want to make sure that your quote package includes, it doesn't have to be exact, but it's going to have a decent idea of what the packaging cost is going to be. Does that make sense, Brandon? I'm going to take a break and ask you if you have any questions.
Yeah, it makes sense. It's reminding me of the the entirety of if statements through coding, the whole decision chart. So kind of following that understanding of everything.
Okay. All right. So again, that's why it's just really important early on to be involved, because you can see, did the quote package include a recommended container quantity? I'm going to zoom out. Okay. So this is all the no. So let's see what happens if you know that the product needs dunnage, but it's quoted without dunnage. Okay, so for this one, it says, is the supplier for this part in the lean vision territory? Don't really know what that means. They probably have some edict or some plan where they're trying to get their suppliers to institute lean manufacturing. That's what I'm thinking. That's what it is. But this would affect what they do. So for example, if they are moving to lean, and you'll see this in this supplemental video I have later with Steve, who was around when packaging became returnable in automotive. He talked about lean and how that was part of the whole process to get lean manufacturing in, was to have returnable packaging. So if they are part of the lean vision territory, yes, then the container will be returnable. Okay, that's another thing I mentioned before. If they've quoted this expendable pack, and in the quote package, and you answer no, then, oh, wait a minute. Okay, so if it recommended a container and it's good, and you say yes, does it fit into the recommended container? So I'm going the wrong way, but we'll keep going down this way. So if the quote package included recommended container and estimated quantity, No, it didn't. If it did not, then that means that they may have quoted packaging or they may have not quoted packaging. So you don't know what it is. But again, if it's for lean, if it's a lean supplier in what they're doing in this in their products and projects, then it's going to be returnable. So they're going to go here. Is the supplier on a closed loop system? So that means that are the containers, if they're using returnables, do they have a truck route that picks up from the supplier, maybe goes through some sort of distribution center, maybe not. But the whole point is that it goes from the supplier and it makes it to the assembly plant of their customer, whoever it is. And then there's a route to send it back, maybe through a distribution center, maybe not. But the whole thing is that from the supplier to the customer, there is a route that's circular in some shape, manner, or form, where it's gonna, these returnables can get returned back to them. And here it says, is a supplier, okay, so they say no. Is a supplier on a viable closed loop transportation system? So viable to them means within 250 miles of the plant that they're trying to get it to. Or it could be 250 miles with a distribution center if they're using distribution centers. So that means they feel like they can keep track of the packaging better. If it's too long of a route, that means that the driver might have to stop. You know, I think 250 miles, really, you figure that's about how much a driver's really going to make it through during a day, because they're probably going to have city traffic. They're going to have to stop for breaks, they have to stop for lunch. They can only drive so many hours a day. Even if the highway is 70 miles per hour, some of their drive is not going to be 70 miles per hour. If they're driving in the Midwest, they're going to be hitting, you know, highways of 70, maybe 2-lane highways. Then they're going to hit a small town. And anyone that's lived in or driven through a small town in the Midwest knows that you're going to hit you're going to have your speed, you're going to all of a sudden hit a small town with 1 or 2 traffic lights that the speed limit's going to be 35, and there's going to be maybe a state trooper waiting to catch someone. So everyone slows down. So you're not going to be doing 70 if you're a driver through that. So theoretically, 250 miles per day is a realistic distance for them to travel. If this was no, then you have to do a business case on the cost of transportation and everything that's involved. So they probably have a format for developing a business plan. So when I mentioned before about justifying returnable containers, every company has their process, not necessarily standard. It's not standardized across automotive, but they generally looking for a lot of the same information, because they're looking to see how much will it cost over the long run. Will it save them money compared to any other type of container? So that's what they're doing the business case here. And you can see it starts routing them to a couple different other places at this point. Okay, we're going to go back up here. As a part of the lean vision, we didn't know, but they're still trying to drive them towards returnables. If you said yes, then it's already been decided, it's in the contract, it will be returnable. But again, you want to make sure even this one doesn't have it says a quote was not recommended or included the package, but they may have wrapped in the cost for this $10 pallet versus $100 pallet. And they haven't done any of the justification to say over 5 years or 7 years, the cost of using this pallet could be $1 million. Whereas with a returnable pallet, they might be spending $250,000. So that one-time chunk may sound like a lot compared to a $10 pallet, but when you take that volume over 5 years, it could really add up. So, you know, that's part of this business case again here. So now you can see this is the meat of this whole decision chart. Back up to here, because I want to make sure I cover that, because that's what I was kind of talking about first. If the quote package does include a recommended container, again, maybe they recommended this one versus this one, okay? Does the part physically fit into that recommended container? Yes or no? So if it's yes, you've kind of bypassed a lot of things here and you're done. So you have a lot of things here. And the reason why you see this is because if the quote package included a recommended container and estimated quantity, now all that they're doing is confirming that the part fits into the container. What's important here is, again, making sure that from the packaging function that you are part of this decision, because if the decision's made from the supplier, they're going to do what may be advantage and more of an advantage for them. And purchasing may be happy with it because the cost is in line with their budget. But it could cause problems down the line where, you know, maybe they recommended this palette, but you have a clean room setting. So really, maybe you should have a palette like this, or maybe gotten rid of wood pallets for whatever reason. Maybe the part's heavy, much heavier than other ones have been. So now you're getting broken pallets. And that could be an issue because maybe you're putting engines on these pallets and the pallets are breaking because the weight of this part is so heavy. Just giving you some crazy examples. So, okay, so if it doesn't fit into the recommended container, so the only criteria they're giving you is, does this part fit physically into the container? But I would challenge this. Like if I worked at this company, I would challenge this decision chart, because the size is not the only thing that works out for this. Like, why was this container recommended? Because if they recommend a bulk bin, but your manufacturing team only allocated room on the line for a small tray, you know, what do you do there? That could be an issue. So I would personally challenge this, because I think that, yeah, it could physically fit in here, but you may have some other issues on the line with it. So really, I think many of these would probably end up going down this decision tree anyway, because even if it fits physically, maybe there's some other issue. So this is saying, is it going to fit in? If no, it doesn't fit into the recommended container. Okay, so I'll just basically say, does this part meet the requirements for shipping in this recommended container? Yes, you're done. And now you go back and you bypass all this, but no, it doesn't fit the criteria that you've set aside, that you've determined to be important for packaging. So now you're looking to see this fit to a manual handle container. So now you're going again to the handheld tote. Yes, you've got a lot of things to look at. No, will it fit into a 32 by 30 container, which is a smaller automotive standard. So instead of like 48 by 45, there's another pallet or bin that would come in a 30 by 32 footprint. That is an automotive standard. It's smaller, so a lot of people maybe don't use it, but it's bigger than a tote. It gets handled with forks like this. It looks like this is just a more square version of it and shorter version of it. So again, they're trying to push towards handheld container. If not, can you get to the smaller bulk bin, smaller roll pack version? No, then you're looking at one of the bigger roll packs, the 48 by 45, or maybe a bigger standard even if necessary. And then it says here, you set the standard pack quantity at the capacity of the container. So again, the same thing, you're looking at what you have to know, the capacity, the weight capacity of that container, which was in the homework last, for the last homework assignment, because you want to make sure that you're not overloading that container. Because once you start overloading this container, let's say you're putting a bunch of heavy metal parts in here and you max it out, say if that capacity is 2,000 pounds, you want to try to put 2,500 pounds worth of material in here, then this row pack would fail. So you want to make sure you stay below that. So with the handhelds, it's what can someone carry? The average person that's not super strong can carry, versus for a bigger bin, you're looking at what can the container itself carry or hold without breaking. Let's see. Here are some things like does a part leave a residue. So clearly this is a facility that looks at they're using parts that are oily, or maybe their parts are sensitive to oil. Most likely because they are using two different color containers in this facility. They have oily parts and they have dry parts. So they put their oily parts in a gray container. So that kind of tells people from a distance, okay, gray stays over here, they're dirty. The green ones, if we don't expect them to be dirty, we don't expect them to have oil in them. So that kind of gives them a chance to keep them segregated. Again, you're looking at the smallest tote you can have, and they're calling it a manually handled container, but it's a handheld tote. Like a 12 by 15 by 5-inch tote, or 24 by 15 by 9-inch tote. These are all modules of that 48 by 45. They're all, you can multiply that and get them evenly on a 48 by 45 standard automotive pallet. And then this talks about that loaded container weight. Does it meet their guidelines? And more than likely it's going to be that 30 pounds. That's what it sounds like, because you're talking about handhelds and they're talking about their weight guidelines. This one even gives you an option of leaving in an expendable. But the assembly center, which would be their assembly plant that is going their customer, would have to agree that expendable is okay. And it comes down here. So you see they have a lot more decision points that they're looking at. This is actually probably more realistic on a lot of the decision points of what you're looking at. You may not have it all written down on a flow chart. You may not think about it. Some of the things are just kind of second nature. This one here gives you the basic steps. This one is breaking it out a lot more. But those are actually both pretty good, and they're both pretty useful on making decisions. Here, they have their points where they say stop, and if there's an issue, then they have a group that you would talk to and work with, which is good. So for this is probably a group that's tied in with the program management team or purchasing. But as a packaging engineer, no matter what company you're at, you want to be part of this group or be tied in with this type of group. And then here, this is, this is their forms, probably their specification form that puts it in the system. So anytime you make a decision on a container, you're going to put it in to some system, whatever system the company has, and it would become an official specification. Okay, so I think that covers that. Okay, Brandon, your turn. I'm going to grab some water, but your turn to think of any questions for the class.
Yeah, as I said, I actually don't have any questions on that one. It just, it definitely is a lot, like to look through and to make sure that you're staying on the correct path and whatnot. I remember having to put one of these things together before, and it was like a nightmare because sometimes you'll reach steps that are repetitive, like just because you've passed it once doesn't necessarily mean that it won't appear again later on in the chart. So I remember these things.
Yes. Yeah. So I would say you want to keep something like this handy. If you're working for an automotive company, you might want to take something like this and modify it to, um, to the company that you're working for, just to make
Mhm.
sure that you're covering all the bases. But the basic premise of saying, can we start with a small handheld tote? And if not, do we do something bigger? If not, you know, these become exceptions, and then you start managing exceptions, and then you have other people that you need to make sure you're in touch with, because you're basically managing that exception and letting people know.
Mhm.
So, okay, parts per truckload. So I tried to look this up because I wanted to update this. Trucking companies, a lot of times, if you go and order a truck, they'll charge you by the truckload. Now, some of the larger automotive companies and tiers, they will negotiate rates, and they can be very complicated. But if you just like looking for a round number, so prior to the pandemic, $800 per truckload was probably, that was a good deal, a well negotiated trucking rate, right? Now, I was just trying to, because it, like I said, changes a lot. I'm gonna try to see if I can find where I did look it up yesterday just to see what the most recent was. And it ranged anywhere from, I think, $1,800 to $5,000 for one truck. So it's gone up quite a bit. Part of that has to do with labor, part of it has to do with the cost of fuel, but this is going to kind of talk about like how many parts you can get per truck. And it's important to know, because then you can take the cost of a truckload and divide the number of parts per truckload to get a cost for your freight or your trucking for each part. Because in automotive, the purchasing team, they charge on a piece price basis. So they want to know for this one part, how much does everything cost for it? So they want to know everything from, I'm trying to think of an example here. Okay, so let's say you have this stylus, right? They don't want to know necessarily the cost. The assembly plant might want to know this assembly, what's the cost of this assembly? But the people that are assembling this, they're going to want to know the cost of the stylus tip. They're going to want to know the cost of this trim. They want to know the cost of the blue barrel. They're going to want to know the cost of everything. And when they talk about the cost, they want to know how much did the material cost for this? How much material was used for this stylus tip? And not only how much material did the material itself, the raw material cost, but they also want to know how much did it cost to make this? So if there's a tool involved to make this rubber tip, energy, fuel, labor, everything just for this rubber tip, and then the transportation of it and the packaging of it. So if this, for example, this came wrapped in a plastic sheet, and then it went inside a carton, and then that carton was put in a box, and then that box was put on a pallet, they would want to take the cost of all that and divide it into that rubber tip. If they're shipping, let's say they're shipping these rubber tips in on the packaging, in a bag, and those come in a carton, and then they come in a box. So they will get that detailed in automotive. So that's why we're kind of talking about this. So again, I mentioned that this truckload cost in most cases it's based on, how much distance is traveled. But I've seen in automotive companies where the supply chain team and purchasing, they have taken cost. They'll use companies that will broker out the trailers. So when that happens, they'll have a fuel surcharge, they'll have a mileage charge. There will be a lot of different charges that they've broken out because they want to know for each load which is more advantageous. And depending on the load, some of these loads, depending on that route that they're on, it might cost more for fuel. Or if the price of fuel goes up, then they might want to lock in a fuel rate. So they would get a surcharge because they've locked in this fuel rate. So they're paying the same amount. So say a company that's done a good job of negotiating pricing and breaking out everything. Let's say that they're charging, let's say their surcharge, let's say that it is, I don't know, I'm just making up numbers right now. But let's say that they set $3 per gallon, right? For their surcharge, it adds up to that. I'm just making this up. So right now, that's great because, we're seeing gas, ranging between $4, $5, $5.50, right? Depending on $6, depending on what part of the country. So right now they're getting a good deal. However, at the beginning of the pandemic, gas dropped to about $1. So I don't remember what diesel was, but in general, diesel years ago used to be cheaper than gasoline for automotive vehicles, for personal vehicles, and then it went above. So the reason why they, negotiate, breaking out a lot of different charges is so that they can manage what their costs are going to be across, it doesn't change or fluctuate that much. So when fuel is really cheap, they might be paying extra, but when fuel goes up, their price doesn't go up above a certain point. So for them, it balances out. Okay, so here, we talk about the weight. We've talked about the weight limit before, about 45,000 pounds. So if you have heavy parts and you put them in bulk bins, normally you can fit 52 of these bulk bins in a trailer, right? Because this 48, 45 footprint, you can get 13 down a row, get two rows next to each other in a truck, and then you can stack it 2 high. So you can get 52, 26 per layer, and then 2 high. So if you have 52 of these, even if your capacity is 2,000 pounds for this, if you put 2,000 pounds in this, but you've got 52 of these, I'm sorry, on a trailer, now you're over 100,000 pounds. So you have more than doubled the weight limit on this truck. So, now you're back to that question that was on a homework last week, that was about a rail car, but you're going to do the same thing if you're overweighting a truck. First, it's not legal. When they go through the weigh stations, they will get kicked off if they can even get to that point. They will get fines or whatever else happens to their loads when they are overweight. If they can drive that far and if it doesn't tear up the vehicle, their transmission or their shock absorbers or anything like that, if it doesn't tear up the vehicle, they're not going to get far. So, first you want to maximize. So taking weight out of this, knowing that you have parts that aren't going to weigh out a trailer. Now what you want to do is cube out your trailer. So you want to get as many of these, you want to put as many of these full of parts into the trailer as you can. So you want to get all 52 of these bulk bins, for example, filled with parts as you can. So you don't want to send 52 of these and then the bin's only half full. You want to fill it up with parts and ship it. So It's a nice little fun dance, but okay. So again, what they're trying to do is have fewer trips, because if you send a load that's half full, you're making twice as many trips. So you want to try to get as many parts as possible. Okay, so I mentioned before that there are weight limits that are based on state and federal government limits. And besides, tearing up the suspension, they do take longer to stop. I don't know if you've ever had the experience of being on a highway or on a road and having a truck right behind you that stops and you don't think they're going to stop. And it might be because the stopping distance was too short. It might be because they had bad brakes. It might be because they were going downhill, or it might be because you cut them off and at a light that was red and they knew what their stopping limit was. But now that a car gets in between them, it's decreased their stopping distance. So if their trucks are heavier, it's much harder. It takes longer to stop. So that's partly why you have, weight limits. You have things like rollover accidents. When you see on the freeway or on a highway, you see the sign that shows a truck tipping over, that's alerting the truck driver that if your truck is easy to tip for any reason, you need to slow down. So the heavier the trucks are, the more you're going to see these things. And then things like potholes. So you probably also notice that if you're ever driving on a highway or a street, trucks will tend, in many places, they're supposed to drive in the right lane, or onto the lanes on the right hand side of the freeway or the highway or the street. Those roads that are more heavily traveled by trucks, you'll see more potholes, you'll see more wear. If you've ever seen the left hand lane and it's pretty smooth, but the right hand lane is uneven and has potholes or just has dips in it from the trucks, that's why. It probably over time, even though the cement and asphalt specifically, it looks solid, it's moves over time. It can move on a hot day, but it also, you'll see cement cracking during the winter time when the water gets underneath and freezes, and it freezes and it pushes the cement up. So, these are some of the things that can affect the performance of a truck, and it affects it even more when the trucks are heavy. Okay, so this talks about, where I kind of mentioned about weigh stations, right? You're not going to see a weigh station on Grand River, right, in front of Michigan State, but you will see a weigh station on 96 or 23 or any of those, when you're on a highway. Maybe not 23, I'm sorry, because it's not necessarily interstate, but 96, you will see I-96. When you're out, you will see weigh stations for to weigh the vehicles. You'll see here that the weight is restricted to 80,000 pounds, but you have to have a special permit. Here, the trucking companies, they do try not to exceed the 45,000 pounds, because then you're, dealing with, difficulty in performance of the truck, more accidents, more issues, more wear and tear on the vehicle. But that weight limit here of the 80,000 pounds, you're looking at not just the trailer, but you're looking at the tractor. So remember, the tractor is that's what contains the engine. It's going to contain the transmission. Sometimes drivers basically, live in, that's where they use, instead of having a hotel. So they might actually have an extra cabin where they can sleep back there, or, they can cook or do, basic things while they're on the road. So, some drivers have chosen to do that versus staying in hotels, but that adds weight to that whole system as well. So here is the, where you've got your tractor and then you got your trailer, and empty alone is 15,000 pounds. So remember here, we talk about the 45,000 pounds. That is, you already have this empty trailer. You can see how much the trailer and the tractor alone is at 35,000 pounds. So, so this is where they come up with that 45,000 pounds of product, because you've got that 80, subtracted the trailer, subtracted the tractor here, and then you're at 45,000 pounds. So just keep that in mind. Okay, so we talked before about some of the standard heights and lengths of the trailers. What you're going to mostly see in automotive on the highway for the long distances, you're going to see 53-foot trailers. Sometimes you're going to hear about milk runs and bobcats and things like that, where they might be using a 20-foot trailer, 23-foot trailer, or 23-foot truck, or 15-foot truck, or something like that. Those are usually going to be more localized drives, where they may be shipping across the street or in town or across town or something like that. But what is going on the highway for the longer distances is generally going to be that 53-foot trailer that you all look to calculate. I think it was in homework number 1, where you're saying, if you have 400 trucks coming in a day, how much space does that take up? And you have to calculate the square footage, the floor of the trailer, to measure the floor square footage of the facility of what would be needed. So most of the trucks are that standard 53-foot trailer. So you pretty much stay within that standard. And that tells you, what the height, here it shows that the height inside is 110 inches. When you look on that chart from chapter 1, however, most automotive companies, most packaging engineers, when they measure, they just go and they just kind of say a rough 100, because that gives you room for clearance. That gives you room for if there's a buckle on the height of the trailer or even damage on the door. And it gives the fork truck driver a few inches of clearance. So if the fork truck driver is kind of unsteady, or the fork truck driver can't necessarily see in the trailer because it's dark, or for whatever reason they can't see in front of them, they have a few inches of grace so that they're not damaging parts or damaging the trailer. So here it says a clearance of 4 inches is allowed for loading. Yes, but really the guideline, the general rule, or best practice, or just like a general guideline, rule of thumb, is going to be, just say that your pallet load shouldn't be more than about 100 inches. Anything more than that, you're going to start seeing, you might start seeing damage with your driver, or loading or unloading or something like that. Put this in before it dies. Okay, so then next we're going to talk about, we talked about how you make a decision on which pack to use, getting an idea of how many parts fit in a pack, and then also looking at how do you maximize, you want to maximize the trailer, you want to maximize the parts in the bin or the handheld tote to maximize the space on the trailer. And by using these standard returnables, you're automatically going to max out your height, whether you have 2 or 3 of these. For example, if it's 34-inch and you go 3 high, versus a 50-inch one, you go 2 high. those are already standardized. So you have those guidelines, if you use those standards and then you put as many parts as you can into the standard packs, that's how you maximize what's going into your trailer. Okay, this gives you an example of how to arrange parts inside your container. So I've seen this over time where people try to come up with some calculator or some process where they can just come up with a size, and then from that size, you can take, to automatically tell you how many parts are going into your pack. Okay. But from there, what happens is a lot of times it'll orient the part in a way that doesn't really work. So for example, here's a radio. And I'm trying to see how this one goes. Because, okay, so I'm trying to think of a couple of examples. So I've seen things where you have parts that have an A surface and a clip. And if you just take the general dimensions of that part and you use one of these programs, it might put them upright. And it might put them upright and nest them together. So the clips are going here, or it might nest them this way. So the clip is touching the A surface. So the program doesn't necessarily know like what parts are A surfaces and which parts shouldn't touch. It just looks at jamming as many of these into the system as into a tote as they can. If that means that, they take these two and they put them this way because you've got empty space here, and then you can nest that together, that's what the program looks at. So just keep that in mind when you see these programs. Sometimes they don't always work. It'll tell you how many you can get maximized, but if you start shipping it that way, maybe the parts get tangled, maybe they get scratched, or maybe, half are up and half are down. So now you have the operator doing this, and now you have repetitive wrist injuries or something like that. So just keep those things in mind. Okay, so this tells you they're assuming that this player, and you can tell this is old because it's an AM FM CD player, which I still have in my car. But this tells you that you can put them in any orientation inside the tote. So you can put it on his side, on his back, however. So maybe you're putting, some are up and some are down. But then you start looking at, how is the operator going to be unloading and loading this into the car? When they take it out of the pack, are they going to have to orient it and turn it a certain way? Is that going to slow them down? Is that going to slow down their tack time? And, those sorts of things. So, okay. Then we go here. So you've got your dimensions. And I mention again, when you get a part, if you can get a part, that's always great. Measure the part. Compare to the drawing. This is probably what you're going to see on the drawing. You're going to see like maybe this dimension and this dimension, but not this dimension. Or you might see this dimension and this dimension, but you won't see the third dimension. So just keep that in mind. So if you can have a part and you can measure it yourself and compare to the drawing, that's great. Because there may be things on the drawing that you can't really see. It's like on the back right now of this, there might be some sort of clip or something that, even though this is just over, about 10 1/8 inches deep, this might be sensitive to, this could be some sort of plug or port for the electronics, and it might be sensitive to pressure. So even though this is saying it can be oriented in any dimension, any way, if you put this radio here and there's some sort of clip or something or electronic component underneath, it might damage it. So, you know, just keep that in mind. So this is making an assumption that all these things have been checked and it can go in any orientation and you've got all the dimensions. It also tells you that 1/4 of an inch separation between the parts should be allowed for protective dunnage. So this is telling you that, you know, this part needs protection. You've got some Class A surfaces on this side, but you also know that you've got things like buttons that, or knobs that could get knocked off. Here on this side here, you might have some venting or some cuts in the sheet metal, and those may be sensitive to getting hit. Maybe they have to be in a certain exact position so that this can actually load into and lock into the dashboard. And then back here, there may be some componentry that if it gets touched, it could cause some damage. So this might be, even though it's in any orientation, you still need that 1/4 of an inch separation. So, and you're using protective dunnage maybe to protect this component. Okay, so once you know all that, they've already determined, let's say they did their wonderful flow chart and they figured out that they're going to need, it's going to be a roll pack bin. Okay. And they've got some Orbis totes, which are very similar in size that they're looking at. So you've got here the big one. So this is an 80 by 48 by 34. So the 80-inch roll pack bin, it's a long bin. It's almost like 2 of these put together, basically. It's a very long bin. It is a standard size, but it's huge. It's probably going to be used for something like trim or something that's really long that you need to protect. But it's very long. The 48 and 34 inches means you're going to be able to stack those 3 high in a trailer to get to that 110 inches roughly and have a little bit of play for your truck driver. The roll pack bin number 2, which is the 48 by 45 by 48, which is basically that standard that I've been talking about this whole time. 48 inches, you stack 2 high. By the time you get it in, it's going to be roughly 50 inches, give or take a couple inches, but you can't go more than 2 high, because if you go more than 2 high, you're not going to fit through that 110-inch door at all. And then roll pack number 3, which is a 32 by 30 by 25-inch bin. That is that one that I mentioned. It's like almost a baby version of the roll pack. It's almost square and it's 25 inches high. So you can actually get 4 of those high in a trailer if you need to. Then you can see what the inside dimensions are. You get your weight of the bin empty. So you can see that big heavy roll pack, the one we've been looking at with the doors that drop, or, you know, something like this, that's a 48 by 45. Oh, sorry, that's the 80 by 48 by 34. That's the one that I mentioned that is basically going to be the length of 2 of these. And you can see that bin alone is almost 300 pounds by itself. And then this alone, a roll pack with the drop door, that one's 175 pounds. So that alone is pretty heavy as well. And then that little baby roll pack is 50 pounds. And then you can see what the weight capacity of these are as well. Okay, you'll notice it mentions the OD, which is outside dimensions, and then it also mentions the inside dimensions, because that's really the room that you have to work with. So where you might have a box where you have the inside versus outside dimension, that would be like a 1/4 length, 1/4 width, and 1/2 for the height, because you are accommodating for the thickness of the box from, you know, outside to outside, and what you have on the inside is, you know, what you have to work with. The totes are even thicker. You can see that they're thicker. I hope you can see that. They're definitely thicker than corrugated. So it's important to know what those inside dimensions are. So here you can see on this one, there's an inch difference in the height. On both of these, the width, you have like a 2-inch difference on the width. And then on this one, you've got quite a bit. You've got a good 3.5 inches on the length. So you can see the differences. You know, you have quite a bit of difference between the ID and the OD. So this is really what you're looking at here to determine how much space you have to work with, what can go in there. And then you can see for the tote weights. So, you know, this is the Orbis tote. It's a handheld tote. It's 48 inches long, which is going to be the same length as this, or the length of your pallet, because this is going to go on a pallet. So the tote is going to be 48 inches long. So it would fit the length of a pallet. It's 22.5 inches wide. So it is half of the 45-inch pallet. And then it's 7.25 inches tall. So it's a very long, narrow, and short pack. The next one is a 24 by 22 by 7.5. So the 24 on a 48 by 45 pallet, you're going to be, instead of one across, one the length of this pallet, you're going to have 2 across. So you got 24 for that 48-inch length. And on the 22-inch side, you're going to get 2 across, because it's half of the width, so the same as the other one. And it is 7.5 inch tall bin. So it's slightly taller, not much. It's still a short pack, but it is now you're going to fit 4 of these across on the base of a pallet, 4 per layer, versus a 12 by 15 by 5. The 12, you're going to be able to get 4 across and 48-inch length for that 12-inch dimension. For the 15, you're going to be able to get 3 across on the 45-inch dimension. So now you're looking at 4 by 3, so 12 per layer. And then they're 5 inches high. So I didn't talk about this yet, but if it's 5 inches high, you know that these Orbis, these handheld totes, are going to go on a pallet. Pallets roughly 5 inches. Okay, just rule of thumb. So now you want to keep your unit load at 50 inches, because again, that rule of thumb of 50 gets you too high of these in the trailer. If you're putting handheld totes on a pallet that's 5 inches, now you want to be able to stack 2 pallets high. So you take that 50 inches that you go stack twice to get 100 inches. So let's go back to the pallet. So we know we're looking at a 50-inch pallet. Unit load, I should say. We're looking at a 50-inch tall unit load. Subtract out the 5 inches for the pallet, and now you got 45 inches left for your unit load total for the height. So since this is 5 inches tall in height, this 12 by 15 by 5, then you're going to be able to stack them 9 high. So again, you're going to have a 5-inch handheld tote. You're going to be able to stack 9 of them high. That's going to be 9 times 5 to equal 45 inches tall, plus another roughly 5 inches for the pallet. That's going to get you to about the 50 inches. And then you can stack 2 of these pallets into a truck. Likewise, for the ones that are like 7.5 inches, these are going on that same tote. I mean, so the same pallet. These totes are going on the same pallet. Subtract the 5 inches from the 50, you get 45 inches. And then you can take the 45, divide it by 7.5. So I'm going to use my calculator today. 6 high. So you're going to get 6 high by doing that. The ones that are 7.3 you're going to get slightly over 6. So you're not going to go a partial layer. So you're just going to get 6 high for that one as well. Okay, this is telling you like how many toes per layer. So for this one, we talked about getting, for this Orbis tote number 3, you get 9 layers, right? And I told you before, you would get 12 per layer. So that's where this 108 comes in. So again, I told you that you've got the 12 by 15 by 5. You can get 4 along the 48-inch length times 3 on the 15-inch length. So 4 times 3 is 12. And then I showed you how to calculate the 9 high by subtracting the 5-inch pallet from the 50. And then you have 45 divide the 5 inches of your height by 45 to get 9. So again, you get 9 high by 12 per layer to get the 108 per unit load number of totes. And that is part of the beauty of having these standards, because even without, once you start using them, you don't need to sit and use your calculator. But, I wanted you all to see what that looks like. And these are the same way. That's how you can tell how many you're going to get per tote. You're always going to get the same. So this one, again, was at 48. So you're going to get one length, and then a 22, you're going to get 22 and a half, you're going to get 2 across in the 45-inch dimension. So you're going to get 2 per layer. And I mentioned before that you're going to get 6 layers high, no partial layer. So the 6 high times 2 per layer, you get 12. That's how they come up with these numbers. And this tells you what the outside dimension is of that full unit load. And this gives you the weight of those unit loads when they're empty, what those totes are empty. Let's see. Okay, so when if you buy a pallet of handheld totes from Orbis, really from any of these, you've got Bradford, there are a bunch of other ones. They're going to sell you the whole pallet. They're not going to sell you one tote or one pallet. They're going to sell you the pallet with 12 bins, or a pallet with 24 bins, or a pallet with 108 bins. They're going to sell that to you. Depending on the company, some companies want you to, they're specified, and this is something that you would make the determination to. Generally, this has already been determined. You'll see it because they've been making the same parts for years, and they've learned that sometimes a top cap is sufficient. Sometimes it might need to be strapped, but sometimes they need a seat belt. And the seat belt, we talked about that earlier in the lecture series. The seat belt is an actual seat belt, and it's just like if you're on a plane or in a car, and it has a seat belt clamp on it, and that's how they lock the lid to the pallet. So they'll stack that pallet up with the totes, put a top cap on it, and that cap will be, instead of stretch wrapping or using strapping, it will actually have seat belts, and it will lock with seat belts and stay secure. Let's see, what can I tell you about this? I talked about how you determine how many. So once you know, okay, so for example, once you know, if you pick this tote and you figure out how many totes go per pallet, you're gonna have 108 totes, and you know that your weight of your tote, let's say your weight of your tote, it's gonna make up, I'm gonna use my calculator again. Okay, let's say that you have 108 bins of the Orbis handheld totes per pallet, right? Let's say that you have 5 pounds of product in each one. Okay, so that's 540 pounds of product for the unit load of the parts, just the parts alone. Because you have 108 of these totes, and you have 5 pounds of parts per tote. Okay, so now you're at 540 pounds. You know how much your material, your product that you're shipping, your parts weigh. So now you need to take that, but you can see that there's a weight of your unit load, which is going to be your totes. And I believe this should also have your pallet weight in here too. I don't know offhand. It doesn't say it, but it might. But it's giving you a unit load weight empty. So I would assume it includes that. So now you're going to take that 540, which is just the weight of your parts alone. If we did the 108, we multiplied it by a 5 pound part, 5 pounds of part in your bin. And you're going to add the 307.6. So you're going to add the unit load weight empty. So now you've added you've got your, you know how much your parts weigh. Now you're going to add the weight of your packaging. So you add your packaging weight and your part weight together. Now you're at just under 850 pounds, 847.6 pounds to be exact. So that's how you can tell how much your unit load is going to weigh. Okay. So let's just say that this company is shipping a whole lot of these parts to the customer, and they're shipping out a whole truckload. Okay. We already talked about how these are standardized, and you can get 52 of these pallets on a truck. So now you want to say, okay, now I know the weight of one unit load with the packaging and the parts. Okay, so I've got the tare weight of the packaging and I've got the tare weight of the parts. So I've got my whole unit load weight. I know that each unit load weighs 847 pounds, 0.6 pounds, right? But you also know that you can get 52 of these pallets with parts and totes in one truck. So I'm going to take that and I'll multiply this by 52. And I know that this is 44,075 pounds, 0.2. Okay. Let's go back here real quick to see what it said. Okay. The total weight should not exceed 45,000 pounds. So what does that tell me? That I'm good. So once I take this 44,000 pounds, add this to that tractor weight of 20,000 pounds, plus the 15,000 pounds of the trailer empty, and add that 44,000, I'm just under 80,000 pounds. So I'm good. Now, if these parts weighed anything more, I think we'd have a problem with the weight limit. Okay, so back to the example with the radio. Okay, so I probably just threw in a weight and threw you guys all off, but I just wanted to use a round number just so you can see how these can add up. Okay, so the unit load weight is combined weight. Yep, so it includes the pallet, the totes, the top caps, and the belt. So that's the whole weight. So now we know that what that weight of that pallet is. If your parts total weight in that tote weighs 5 pounds of parts. So let's just say, I'm going to see how many this fits in. Okay, so we'll say that we're using this tote and we can fit 5 radios in there. I'm just going to make round numbers. So let's say based on that, you figure out that you could fit 5 of those in this tote. Each one of those weighs a pound. And if you try to fit one more in, you're going to have an issue. It's not going to fit on the trailer. It's going to be too heavy and you won't be able to ship it. So that's kind of how we calculate that. Any questions, Brandon?
Yep. So when it comes down to like 45,000 pounds is the biggest load that we can get. But how strict is that? I know you mentioned if you go above it, we're going to start having problems. But like, We talking like a couple thousand pounds, or is it to the hundreds?
Um, that's a good question. I've never had that happen. I would have to look that up and see, but I just know that that's something that when we look at the packaging, we won't go above 45. So if it's like 45 and a half, 45,000 and 200 pounds, we'll just back it off and make it below 45,000.
Gotcha. And then what about going under? So under the weight, do you think that's an issue? Things just be moving around, or?
No, it should be fine. I mean, if they're fitting in the trailer, if you don't have, this, you have dunnage, the parts are secure. So all this is assuming that you have picked a container that fits the parts well. So it's assumed when you've gone through that flow chart and it talks about fitting the parts into the container, they're assuming that you're filling it and that you're not filling it. There's like a gap of parts in it.
Gotcha.
So
okay.
So this is assuming you've gone through that whole exercise and you've picked a container that the parts are not moving around. You have enough dunnage and the right kind of dunnage to keep your parts secure. So let's say that you're only putting, like this many, for whatever reason, you decided you can only put this many parts into a bulk bin. Then the assumption is that you're going to have some sort of dunnage inside to hold them securely.
Okay. And then you said the price is pretty much like a flat rate. So the price shouldn't fluctuate depending on how much material you have in the back.
Yeah, in general, it's a flat rate. In
Okay.
many of the automotive companies, they have come up with their own. So like this talked about $800 per truck. That's a round number, but I've worked at companies where they have their own. They have like TMS or trailer management systems where they can go into the computer and they can say, this is my load, these are my parts, and it will calculate how much that load is going to cost. It'll pick trucks that are available at the time, based on that route, what the surcharges and fees are based on things like fuel and drivers and things like that at the time of day, the time of the week. It can be pretty complicated. And they'll come up with numbers that way. But if you and I were just to call a trucking company and say, hey, I need to send a load, across, 3 states to get here by this day, it will give you, you'll get a flat rate per truck.
Okay. Because I was trying to understand the relationship between, packaging. The golden rule is no shipping air. So we always pack things up to the top of the trailer for that reason. So I was like, it makes sense if it's a flat rate, you might want to get the most material you can on the back of that trailer. So
yeah, so I think the caveat is that you don't want to ship air, but if this is an electronic part, it needs dunnage, then the dunnage is basically taking up the space. That makes any sense?
Yeah. So the inside of that container. So like air would be, so we do things in distribution. It's like, a single pack versus a multi-pack. And our multi-packs are supposed to simulate packing out a box completely rather than just putting one single box product inside of there. And it just, all that access space isn't being used. So it's pretty much like a waste of money. So that's what the dunnage is for, is to consume that void area and protect the product as well.
Yeah, I think in automotive, you're probably going to see more air. The dunnage is going to be more to protect the parts. An example, a really good example of that is going to be a rack.
Oh, that's what I was thinking too. I've seen some racks that shows up like 2 engines on it, and I'm like, wow, okay.
Yes. And that's because they want to keep those engines separated, but those engines are so heavy
Mhm.
that if they put more on it, it's the engines will weigh out a truck.
Oh,
So that's why you don't see that many, because some of those parts are so heavy. Like when I worked in the engine, on the engine side, we had loads that would weigh out before they would cube out.
ooh,
So
man.
for consumer, yeah, you're looking at cubing out that trailer. You want to get as many parts as you can. But in automotive or in industrial, where you got these heavy, huge parts, you're going to, the trailer is going to be overweight before you fill it up.
Gotcha.
So, okay. Anything else? Does that make sense?
Yeah, it makes sense. That's all I got.
Okay. All right. Okay, let's see. Let's see, we're getting to dunnage a little bit. We're trying to keep track of the time here. Okay, so we'll talk about dunnage a little bit. So, and you started touching on this here already, Brandon. So, a lot of the dunnage you're going to see will be dividers. Okay, sometimes you will see things like foam, or sometimes you will see the cloth that is used to, and I don't know what my cloth book went, but you'll see cloth that's, holding, separating the parts, and it's a smooth material. A lot of times you will see, um, like corrugated, sometimes it's coated with like a Michelman brand coating, and that will make it slippery. And then it can act as a barrier, and it will protect some of these Class A plastic parts. And then once you protect these plastic parts, it, keep them from scratching. So you'll have something like this divider, which is, it can be corrugated. Most of the time you're going to see corrugated, probably because these parts are so big and it's cheaper to do it. And sometimes the parts are heavier. You aren't going to necessarily, you'll sometimes see cardboard, like the paper board, but most of the time this is going to be corrugated. I've seen also some craft paper for dividers where these fold and then they open back up. I don't have any of these. I wish I had one to show you, but they will, you can ship them flat and they'll fan out and open up, and they would act as dividers. So they're still talking about, for this dunnage, the radio. So, okay, this one is a double wall C-flute. So it's a 1/4 inch thick. So that's going to separate those parts by 1/4 inch. So like I said, going back to that radio and the requirement for that dunnage of being a 1/4 inch separation between each parts. Let's see. So for this one, this is kind of telling you like how many parts you can fit into this container. I think this one's probably looking at a, and I think I'll probably get more into this tomorrow. I'll go through this again, but okay, so they're simplifying this so that you can, do this math here. So, okay. So here is saying that you've got an 8-inch thick piece of single wall C-flute glued to each face. So they're basically kind of saying, pretend it's in a carton. And this is so you can kind of picture this space. You want to picture the space it takes up, because if you get it too tight, your dunnage may not fit, because you have a couple things with the dunnage. You're going to be putting parts in at the assembly plant, right? On the line, they're going to be pulling out of this dunnage, and they want to be able to easily pull this out without the dunnage coming out, without ripping it, without scratching other parts. So this dunnage is designed so that the operator can easily pull it out, do their job, and not worry about, trying to rearrange every time they pull out one. Okay, wait, now I gotta, put this back and keep it from getting damaged. So that's one thing. On the assembly end, the dunnage needs to be where the operator can easily pull the part out of the pack and install it. But then on the inside, you also want to make sure that when it's loaded into the container, you want to make sure that you can load it and it's not too tight, it's not ripping that dunnage as well, but it also protects the packaging. I'm sorry, you want the packaging protected parts. I'm sorry about that. So let's see, you've got the fit and weight calculations. So I'm trying to figure out the best way to explain this. So again, they're saying you take 1/8 of an inch thick piece of the single wall C-flute and you want to pretend that it's glued to each face. So you're kind of basically putting this in a carton again. And you're looking at the dividers as a kind of as a carton, so you can get that 1/8 inch piece of single wall C-flute, but by doubling it, now you get that 1/4 inch of separation that's required to protect your radio. Okay. So now this is to help you view that part inside the dunnage. And now you're looking at the length, the width, and the height. So you're taking this part length of 10, basically 10 1/8, 10.12, which would be this here, this dimension. Okay. And then you're adding the 1/8 and the 1/8, 1/4 inch of dunnage to separate it, and you come up with 10.37 inches. And then the width is the 7.72, which is this dimension from side to side. And then you're going to add again the thickness of that material. So the 1/8 and the 1/8, which is the double wall together, is 1/4, and you come up with 7.79. And then the height is the 2.68 inches, which is going to be this. And again, remember, when you do this in real life, try to get a part that's as close to production as possible. Even if it's a prototype, even if it's a 3D printed part, whatever it is you can get. When you're doing something like this exercise, you want to get a part that represents the size of what you're packing, right? Because for this exercise, when you do this, you want to make sure that your part fits inside your pack. And with dunnage, you want to make sure it fits with the dunnage. Okay, so this is, you're taking the area, you're trying to figure out how much corrugated you need for the dunnage. And you're going to take that 10.37 times 2. So you basically took the 10.37, which is here, 7.97, plus the 10.37 times the 2.93. So you are currently, you're basically calculating the volume. And then you're going to take the 7.97 times the 2.93. So now you've got your basically your square footage. You did the inches and you convert it to the square feet. So this also tells you, how you calculate the weight of the dunnage. And you're coming up with 2.63 pounds. Like I said, I'll go back over this again. But you're really doing this because you're doing this by adding this in, you're already calculating your dunnage, because sometimes people will forget the dunnage. They'll just say, okay, this is a tote, and you see how much the tote weighed, and you're like, oh, the dunnage, this really doesn't weigh much, no big deal. But if you look at this dunnage here, by the time you do your calculations, it weighs 2.63 pounds. That's another 2.5 pounds. So if you're using a tote and you have heavy parts and you're close to weighing out your trailer, that could be significant. You may not think it's much, but 2.63 pounds times 108 totes per unit load or per pallet, and then you multiply that by 52, that can add up pretty quickly. So now you've calculated, you generally have your size and your weight, but you're really looking at, how to find this focus fitting on the, your part, which is the part basically inside that dunnage. And how do you fit that into your bins and totes? And you've already by doing this, you've already kind of fit that in there. You're not having to do a second exercise because you already added your dimensions of this into each radio. So now each of these cells is already counted in there, rather than trying to count it separately by itself. And then for this exercise, they looked at the roll pack bins first and totes last. Okay, we'll go through this tomorrow, because you can see you're looking at this. What if you put what we're going to talk about tomorrow is coming up with the cube size and then coming up with the different orientations to say, how can we fit the most in here? I will tell you that this is a really good exercise to do in a no, but many times you're going to really see the parts are going to be oriented a certain way because you really, really want your operator to do the same thing every time. You want it to be repetitive. Sometimes you won't need that, and you just need to maximize the most parts in the bin. So this is a really good thing to do. And like I said, we'll go through this and you can see this tomorrow. So these are some of the different scenarios. So you can see here, this is showing, this is the 80-inch. See, I could tell automatically before I even look, this is an 80-inch long. You can see it says the roll pack table is the bin length of 80, width of 48, and height of 34. So I knew that this should have been, if this was a standard roll pack or 48 by 45 pallet, instead of seeing 7 of these, I would have seen 13. Because I just know it's a standard automotive. So that's one, again, the beauty of having these standards is that you can look at this and say, this isn't a standard or, bin, this is a bigger standard. This is a large one. And it's a standard. It's something you can buy off the shelf, but it's not commonly used. So you can look at this and see, look, they're only getting 7 of these on here. So this talks about the different orientations again. Like I said, we'll go through this tomorrow. I think we're pretty much winding down for the day, but these exercises are showing you all the different scenarios that you could possibly do. It shows you how many you can get for the orientation. And I know too, you're like, why are we doing this by hand? So in automotive, because automotive, a lot of this is done by hand. Like people have tried to do this with things like tops or cape. But automotive standards are a little bit different. So, instead of being the 48 by 40 grocery pallet, for example, it's a 48 by 45 pallet. So if you get in the tops or cape, now you've got to like build your own pallet. You've got to go in and build all your own totes. And you can do that, but it's not used very often because by the time you go and do all that, you might as well just go and calculate this yourself. And plus, since these are all, standard sizes, eventually you'll be able to tell, like, see here, this one is 13. So I know this is, and it's 13 by 2. So this is a 48 by 45. And I'm seeing too high. So it's a 48 by 45. That's almost 50. So, I can just look at this and tell because of the standards, and you start to know exactly how many fit in there. But this exercise is telling you like how many parts to fit into this tote. So this yellow Orbis tote, these are the parts, and trying to figure out what's the best way to put these parts in there as far as orientation. But then once those parts are in there, once you know how many you get, this one, for example, it's telling you 48 fit. So then you can do like I did, where I multiplied it by, 48 or 52 or 108 or whatever that is. You can multiply it and come up pretty quickly how many are on a pallet, how many are in a trailer, and then you could take the weights and add it. So you see, I did some of that in my head, and I had a calculator, but it's good to do it by hand first, because then once you do it by hand and you know what it is and you show your calculations in your work, everybody, then it eventually becomes second nature. And then you'll be like me and you can just ramble and talk about it, and you'll be able to just look at a drawing and see how many fit. Okay, Brandon, what do you think so far? I know there's a lot to go through with all these different arrangements, but we'll go through them.
Yep. Yes, that's what I was gonna say. There's definitely a lot of different things to look over.
Okay. Any questions before we close?
Nope.
Okay. All right. Great. So thank you.